This video is for all those people who still believe in global warming caused by the activities of humans. Climate activists, mainstream press, pseudo-scientists and politicians propagate that CO2 is the culprit of climate change or warming of the earth. This is a very big lie. I will document, illustrate and unfold this big lie with hard facts. The CO2 hype is nothing else but a money-spinning machine invented by the elite. One of the initiators is Al Gore. Taxes on CO2 emissions are already the norm. I'm very concerned that the elite is now instrumentalizing children to serve their purpose. The teachers who led the kids to the streets and skip school disappoint me. Why did the professor not enlighten their students? Are the tutors already indoctrinated? This seems to be very serious. Focus is all on CO2. The real problem, pollution of our Earth, is being neglected. How stupid can we humans become? The spinning globe model, as shown in the animation you watch right now, is an open system. It means the globe is not encircled, has no barriers, and is not in a container. Thus, it advocates to be an open system. The globe is adjacent to the huge vacuum of space. This is one of the illusions of Copernicus' heliocentric system that the world believes in. There is no house, glass wall, dome or an enclosing container over the globe, which would permit greenhouse effects. Think about this.
Good morning, I'm meteorologist Stephanie Abrams live from the White House. Today at 1:55, President Obama will be giving a speech at Georgetown on climate change. And we're here to talk about the science behind what he's going to be talking about. So let's talk about why CO2 makes the atmosphere warmer and warmer. It's the same thing as if you get into your car into the afternoon and it's hot, or you go into a greenhouse and it's hot. Here's what happens. You have shortwave radiation, all of that sun's energy coming in from the heat. Some of it gets absorbed by what's on the ground and then radiated back into the atmosphere. What happens is that CO2 absorbs the heat and it re-radiates it back down to Earth. Those are long waves, and so the more CO2 you have in the atmosphere, then the hotter the atmosphere is actually going to get. So that's why we are trying to cut down on CO2 emissions so that there's less in the atmosphere and the atmosphere doesn't get as warm.
Where is the enclosed system of the spinning globe to obtain a greenhouse effect? Greenhouse effects are only possible in an enclosed system. What do activists mean by the atmosphere? All four levels? If this would be true, the content of CO2 would not be measurable. I must assume that the activists refer to the troposphere only, which is the first or the lowest level of our atmosphere. Air is a gas, not a solid. If the air gas molecules would enter the mesosphere, where temperatures are minus 100 degrees Celsius, the CO2 would theoretically turn into a solid, namely dried ice. Further up in the thermosphere, In contrast, the temperature reach above plus 2000 degrees Celsius. CO2 by itself is heavier than air. Thus, CO2 needs a medium to enable it to get into the troposphere. This is achieved together with the other gases. It is a constant cycle and movement in order to find its equilibrium. The real culprit is pollution, not CO2. Air pollution consists of small solid particles. It is a danger to the human health.
Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us. The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Earth's climate has fluctuated in the past. Atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. Ice sheets, such as Greenland and Antarctica, are melting. The extra water that was once held in glaciers causes sea levels to rise and spills out of the oceans, flooding coastal regions. Warmer temperatures also make weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts.
Let's try another pretty simple process. Let's just take a gas in some volume, V, and over here is going to be vacuum of equal volume, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume once it becomes available.
So in the first diagram we have a container, and we've got gas pressure or air on the left side, and then we've got a divider, and then we create a vacuum in the right side of the container. Now, as we remove the barrier or the divider, we know that the gas, the air, will immediately fill all the available space. High pressure to low pressure, always. In this case, we'd still have gas pressure because we are in a container, giving the remaining gas something to press on. Now we'll go to this next diagram where we're going to move. Instead, we're going to rotate our container, and this time create a vacuum on the top and the gas pressure below. Again, when we remove the divider, we know exactly what will happen. The gas will fill the void. Again, we still have gas pressure because we have a container, which is a necessary antecedent because we can't have gas pressure without the container to press on. Alright, now I've changed the diagram a little bit because I've taken the top off my container. We've made a vacuum on top, and we have gas pressure below. We can only have gas pressure because the divider is there, and we have a container below allowing the gas to press upon something. Alright, so now I have removed the walls in the vacuum and made it an infinite vacuum like we are told exists all around us. We can still have gas pressure though, below and in the container. But what do you suppose would happen if I remove the divider again? Well, if I take the top off the container which holds the gas, it is instantly gone into the void. High pressure to low pressure. Second law of thermodynamics. Well, of course, our gas pressure is all gone. It has nothing to press against and will immediately hold to that second law of thermodynamics and dissipate into the endless vacuum above. Now let's see if we can test the only explanation globe defenders have. It gets them out of all jams, maybe this one too. Will gravity hold the gas to the Earth? Now, if this was the case, if gravity holds gases to the Earth, then it will be quite easy to test this. Now, I don't have a vacuum pump or a chamber to do this test, but many do. I've seen people with vacuum chambers on YouTube. So let's look at this example. Let's say that we are on a sphere Earth and that gravity is, as Newton said, an attraction between masses. So we are on Earth and gravity is pulling down. In the left side of the chamber, we have gas pressure or air. On the right side, we create a vacuum. Okay, now here's the problem for globe defenders and space religious zealots. If I lower the divider just a tiny bit, just bring it down a hair, what do you think will happen to the gas on the left? Is this what globers believe? That only the gas at the top would fill the vacuum? Or would the gas fill the entire available space? Well, if you believe gravity holds the air pressure down to Earth, even though there is an adjacent vacuum, then you have an untested and an unproven claim because the gas will dissipate and fill the entire void. High pressure to low pressure, always.
Well, of course, the climate changes all the time. It always has, and it's warmed a little bit in the last 100 years, apparently.
About 0.8 degrees
0.8
Celsius?
maybe, yeah. Nobody knows whether that's got a human component or not. I mean, most of the warming, for example, was over by 1940, long before there was much additional CO2 in the air. But I do tell them that climate obviously is important. It does change. There's very little evidence that humans are making much impact. And as far as CO2 is concerned, which is the major focus, that's probably more good than bad. Well, I think the main benefit of CO2 is it's the food for plants. Plants really need three things. They need light for photosynthesis, they need water, and they need CO2. Plants are made of carbon. When I hear about carbon pollution, we're all made of carbon. Plants are made of carbon, people are made of carbon, your hamburger's made of carbon. But CO2 is used by plants. If you go to a cornfield, for example, in midsummer, and you measure CO2, it's about half what it would be at night because the corn plant has sucked so much CO2 out of the air that it's now limited on how fast it can make new sugar and grow by the amount of CO2. So if you double the CO2, the corn can grow better. There's more of it there. It doesn't suck it down so quickly. So that's number one, is it's an essential plant food. And the other thing is it gives drought resistance to plants. Because a plant has this problem that when it gets CO2, it doesn't suck it up from the roots. It has to open up little holes in its leaf, and so CO2 molecule bounces around and other air molecules gets into the hole. For every CO2 that goes into this hole, 100 water molecules may diffuse out from the interior of the plant. So the plant is squandering water as it's trying to, make food, from photosynthesis. So if you look at, say, a gram of sugar, to make a gram of sugar takes 100 grams of water. So there's huge amounts of water used in photosynthesis now, more than should be, because we're essentially in a CO2 famine. If you look at
we're in a CO2 famine?
Famine, we have too little CO2.
So at 400 parts per million.
400 is still too small, yeah. If you look at the geological history of the world, we started getting good fossils about 550 billion years ago, the Cambrian.
Yeah.
Since that time, CO2 levels have averaged thousands of parts per million, not a few hundred parts per million, much, much higher, factors of 400, 5, 10 even. And so plants really evolved when there was a lot more CO2 to eat. Now they don't have enough. And you can see lots of evidence for that. There's certain plants, for example, that they're called C4 plants that are adapted to the low CO2 levels we have now. They typically are in hot regions of the earth. Sugarcane is an example. Corn, American corn, maize is another example. But most of our agricultural plants use the old-fashioned photosynthesis, which is called C3. And that's a more efficient way to operate if you have plenty of CO2, but there isn't plenty of CO2 anymore. There's not enough. So as CO2 levels have been going up, the old-fashioned C3 plants, and that includes soybeans and weeds and cotton, actually most plants are C3. They're doing very, very well. I mean,
with an increase in CO2.
With the increase in CO2, very, very noticeable. It's a huge effect. It's worth hundreds of billions of dollars every year in agricultural productivity. So when people talk about the social cost of carbon, it's absurd. The social cost is negative of CO2. Now,
because it's a net contributor.
It's a net contributor to agricultural productivity. That's not. You shouldn't confuse that with real pollution.
So you talked about the benefits of CO2. Is there a downside? Because there has to be. When we listen to the level of discourse about this, how can there not be some downside?
I don't think there are any real downsides. I mean, if you look at the arguments, the initial argument was there's going to be this rapid global warming. It hasn't happened. So it's very clear that the models have enormously exaggerated the warming potential.
Why has that happened? What is it about the models that when you simulate it works and you say, well, there it is?
Well, I mentioned the saturation of CO2. If you paint the barn red, if you put another coat, it's not any redder than it was before. And they noticed that early on, that CO2 has this problem that, it's disappointing that it doesn't seem to make much difference if you had. So they invented all sorts of feedback mechanisms that would amplify the effect of additional CO2. Water vapor, clouds, all sorts of things were supposed to be triggered by the CO2. They don't seem to be happening.
But water vapor is a dominant greenhouse gas anyway.
Water vapor is the main greenhouse gas. Water vapor and clouds.
It is the greenhouse gas, isn't it?
Yeah, 70% maybe. Yeah.
And what about the ice on the caps of the Earth, both the Antarctic and Arctic?
Antarctic ice is probably growing. It's a big, complicated continent. West Antarctica, maybe there's a little decrease, but over most of Antarctica, it's increasing.
Well, I was just
sea ice is increasing around Antarctica.
Yeah.
That's not supposed to happen, according to the models, but it is happening.
And what's happening in the Arctic?
Well, there's a good website, I think it's called Cryosphere or something, at the University of Illinois. And if you Google on it, you'll find it.
Cryosphere.
Cryosphere, and they're pretty honest, I think. And so you can look at the ice this year or last year, and it fluctuates up and down. There's a lot of ice now because we're just coming out of the Arctic winter. I don't think there's anything to worry about from more CO2. I'll say it again, that I think more CO2 will be good for the world, that our great-great-children will look back and say, thank God we've got all this CO2, what foresighted people our ancestors were. I think it is true that you can mess up the world very easily. The American rivers used to be a disgrace. When I first went to New York City, Hudson River was an open sewer, and it's clean now. There are salmon running up the river, shad every spring, and so that's the type of environmentalism that works and is good for us, and that's what we ought to be working on, cleaning up real things that make a difference.
We should keep our planet livable, and if it's getting hotter and hotter, this can give a positive feedback and the temperature can get out of control, and then there is no rescue.
How much has sea level risen in the last 4 years? I do not study meteorology or...
It has hardly risen at all, but have you seen reports in the media that sea level is rising ever more rapidly?
I think so.
There's a phrase in English that climate change is a fact. It's been a fact for 4 billion years, hasn't it?
I think it's so.
In the last 10 or 15 years, has the world got warmer or stayed the same or got cooler?
I don't know.
You tell me, what temperature should the Earth be on average?
Now,
What is the best temperature for the Earth? The temperature today?
yeah, I don't know. It's not every day the same temperature.
All right. And now, most creatures in the world live in the warmer parts of the world. Very few creatures live in the colder parts of the world. So isn't it the fact that warmer is better for health?
No. Well, what do you want me to say?
I'm asking you the question. And are you surprised to find there has been no global warming for 15 years?
You have no doubt.
I have checked the data. 4 data sets.
How do you know that?
Because I take the data from the satellites and I then plot what is called the least squares linear regression trend, which means if you have a stochastic data set, one which jumps up and down, you can process it mathematically to show what its trend is over a given period. And over the last 15 years, there has been no statistically significant increase in temperature at all. Those are the facts. How do you react to those facts?
I think it's positive thinking, quite honestly.
You think it's good news?
It's absolutely good news, yeah.
Please go back to Greenpeace, who organised this event, and all right, and ask whoever has sent you here why they sent you here, now that you know that there has been no global warming for 15 years. I want you to ask them that.
I understand the question.
And Greenpeace is a campaigning organisation, isn't it?
What do you mean by campaigning?
Well, it's not a weather bureau, is it?
No, of course not.
You have a lot of facts. You have more facts than in my head.
Situation like this. We are in Central Kuta and the amount of plastic is unreal.
have the courage to face the realities of our time and allow ourselves to feel deeply enough that it transforms us and our future. Come with me on a journey through the eye of beauty. Across an ocean of grief. And beyond.